Good afternoon, honorable present here. Myself, Dr. P. Janagaratnam, Assistant Professor, Department of Mechanical Engineering, SNS College of Technology. In my previous video series, I already discussed about the different types of cams, followers, and special cam contours and all discussed. Today, I am going to discuss about the types of follower motion and their derivatives. So what is meant by follower motion? So follower motion describes how the follower moves in response to the rotation of cam. While the rotating the cam from the 0 to 360 degree based on their cam rotations, the follower motion will be and moves through the back or uplifting the linear motion. So essential for controlling the precision movement in the mechanical systems, which will be used for an IC engines, reciprocating engine mechanisms, automotive industries, CNC machines, etc. So criticals in engines, automated equipments, manufacturing devices, motion types directly affected the smoothness, wear, vibration. So here the follower motion is very much essential for controlling this kind of wear and vibrations. So performance depends on selecting the right motion. So four standard types of follower motions are, first one is for uniform velocity. So constant speed motions with simple linear displacement. This is the first type of follower motion. Second one is for SHM, simple harmonic motion. So this is the sinusoidal pattern based on the circular motion projection. And then next one is for uniform accelerations, parabolic profile with controlled acceleration changes. Then fourth one is for cycloidal motion, smooth cycloidal curve for an optimal performance. So mostly we have to prefer for an either uniform velocity or uniform acceleration of the follower. So uniform velocity motions characteristics are the follower moves at a constant speed during the rise and return. The rise means the follower is moving through the upward direction, and return means once it will be moves through the upward direction and again it will be return to the return position, and another one is for the ideal position. So displacement diagram, straight line with constant slope. Acceleration is zero during the motion. Some of the limitations are followed means infinite accelerations at start and end points and causes serve shocks and mechanical wear. Rarely used in the practical applications. So this is the some of the limitations of the uniform velocity motion. So simple harmonic motion, here the displacement follows sine waves, projections of uniform circular motion, velocity and accelerations. These velocity peaks at the mid stroke, acceleration peaks at the stroke of the ends. Applications are finite accelerations, which will be used for and suitable for low and moderate cam speeds with the finite acceleration. Acceleration is finite, but the jerk is infinite and transitions moderate. Then uniform acceleration and deceleration motions. The first half stroke is the follower acceleration uniform with increasing velocity. Second half stroke is follower decelerates the uniformly returning to rest. And motion profile, velocity and acceleration curves from the parabolic shapes. And performance is and cycloidal motion, the gold standard displacement follows a cycloid curve, the locus of the point in the rolling circle. Velocity and acceleration start at the end of the zero. Smooth transitions with no discontinuities. Lowest vibration, noise, and contact stress. The ideal for the high-speed cams and precision applications. When comparatively, the cycloid motion which is used for reducing the vibration, noise, and the contact stress. So comparing the motion characteristics, uniform velocity, high shock and wear. Simple harmonic motion means it can produce the smoothness when compared to the uniform velocity. It is applicable for the lower speeds, and uniform acceleration, it is smoother than the SHM, simple harmonic motion. Cycloidal motions, which is finite accelerations and smoothness best when compared to the other three motions, which will be used for an high speed application. So this is why motion derivatives matter means velocity, acceleration and jerk. Velocity means controller follower speed and timing precision. Acceleration means determines the forces on the followers and cam surfaces. Rate of acceleration changes and influences the vibration and wear, and efficiency across the system life cycle which will be increased, and balancing performance will be produced and durability is increased. So this is the summary of this kind of four kind of motion: cycloidal, advantages, derivatives. So this is the overall summary of the mind map, like introduction, classifications of followers and terminologies, and what are the types of motions, and how we can classify it into radial, cylindrical and axial. So this is the sum of the assessment quiz, and this is the sum of the reference. Based on this reference, I have to make this PPT. Thank you. In our next video series, I have to discuss about the one more interesting topics and problems which is related to the CAM design. Thank you.